This is a problem on the Archimedes principle. It's translated from an Italian exam. I deem it a nice exercise to understand more about the Archimedes principle. It's not a complicated problem. I think that it could be solved also by high school students. Anyway, let's read it and then let's solve it together. It won't take too long. A spherical empty buoy whose radius is r and its mass is m is completely immersed in water and anchored to the bottom of a lake by means of an unstretchable massless rope. The buoy is also subject to a horizontal force F. Determine the tension T in the rope and the inclination of the latter. Let's start. So let's consider the buoy. Here we have the spherical buoy, and its radius is a capital R. We have the surface of the water of the lake, and there is a horizontal force F acting on the buoy, and there is a rope attached to the buoy which anchors it to the ground, so to the bottom of the lake. And this kind of rope has a tension T, and it also has an inclination with respect to the vertical line. For example, we can call this alpha, which is the same as this alpha here. And we simply have to calculate T and alpha. So let's consider all the forces acting on the buoy. So we have the force F, then we have the tension T, which forms an angle alpha with respect to the vertical line, and then we have a force mg, which is due to the weight, due to the mass of the buoy, and the gravitational force is mg. And then we have the Archimedes force here, so we have the density of the water, which we call it rho A. A stands for acqua in Italian, so I will use this notation, but you can call it whatever you want. This is the density of the water. And then we have the volume of the sphere, so Vs, and then we have G, the gravitational constant. And the volume of the sphere is of course equal to 4/3 pi r cubed, and then we can write down two equations. One is to balance the forces horizontally, so it means that T times the sine of alpha will have to be equal to F, and then we have to balance the forces vertically. So T cosine alpha plus mg should be equal to rho A v sphere, the volume of the sphere, times g. So let me rewrite the equation below like this. This is equal to minus mg plus rho A vs g. And now it's very easy to solve this problem because we have two equations. So for example, if we want to find the tangent of alpha, we can divide the first equation by the second, term by term. So we divide this by this, and of course the result will be equal to this divided by this. So the tangent of alpha will be equal to F divided by rho A vs g minus mg. And then another equation that we can find is the following. So we can take the square of both sides of this equation, and then we can sum term by term. So we get t squared times sine squared alpha plus cosine squared alpha equal to f squared plus rho A vs g minus mg, and this is squared. Finally, you can see that sine squared plus cosine squared is equal to 1, and of course you get t is equal to the square root of f squared plus rho A vs g minus mg squared. So this is the result. From here we can get the tension and also the inclination with respect to the vertical line.